I was confused when I read the term confusion matrix. Were you also confused? If you are confused about confusion matrix, then this is the video to go. And this is here in this video, you are not only going to learn confusion matrix, but with me together, you will be creating your own confusion matrix that manually. So stay along with me. Before I go to confusion matrix, before I start on all these concepts, I just want to be very clear about why it's used. So confusion matrix, why it's used? It's basically used whenever your model is doing classification, especially binary classification. And of course, whenever I mean here in this video classification, I am referring to supervised learning, which means you are labeling your target output variable. And here, binary classification, which means either it's yes or no, right? So that's where if you want to evaluate those model which is doing binary classification and you want to check how efficient my model is, right? You want to check the performance. Confusion matrix is one of the way where you can check your model performance. In this example, I'm just taking one of the pre-trained model. I'm just calling this model as truck identifier, where you will funnel lots of images of vehicles and then model is saying yes or no, whether it's truck or not. So model is predicting whether it's truck or not. So for imagine this model is pre-trained and now I'm testing my model, and here this is my actual and this is my prediction of my model. So here I'm showing both, but model is saying no. So model is predicting right. Here model is saying yes, which means it is a truck. So here model is wrong. So model is doing wrong prediction. Here the actual is truck and model is also saying yes to it. So model is doing right prediction. Same goes for here. Whenever you say yes, which means model is doing the right prediction, the correct prediction. And here again model is making mistake. So actually it's truck, but model is saying no. I don't know why, but then let's check the efficiency of model. And let's go to the confusion matrix. Now, before you go to confusion matrix, try to understand these two terms, right? This will really help you when we will be creating or take deep dive into the confusion matrix sooner. So here, understand this positive and negative. Now, consider this as like someone is COVID positive. If patient is COVID positive, you will tell positive. If patient is not COVID positive, you will tell it as negative. So similarly, in this truck analogy, if if it's truck, that means I am referring to as positive. If the image is not of truck, I am just telling negative. Now, based on this concept, now I am going to inject a new concept, that is what is true positive, true negative, false negative. So TP, which is like true positive. The true positive means, so all these are properties, and against all these properties we are going to put a count in confusion matrix. So in confusion matrix, actually you would be having this four square box, and each square represents one of the scenarios. So for example, this square represents true positive, this square represents false negative, this square true negative, this square false positive. Don't worry about all these jargons if you're new simply. So basically true positive, and here by the way, in all these square boxes you will be putting the count of actual predictions. That's what you will be putting. So true positive square actually indicates that how your model predicted the positively, which means you pass the image was positive, which means actually the image was of truck, and your model is also saying yeah it's truck. So it's positive positive. Understand this, right? So actually positive, which means in general positive means in general positive means it's truck, it's image of truck. And here also positive, right? So prediction also says truck, and here actually image was also positive, image was also of truck. So this count will show true positive. And here if it's negative, which means actually positive, which means you are actually passing the image of truck, but model is saying negative, model is saying no, it's not a truck. So here it's false negative, so model is falsely identifying a positive image as a negative image. So model is falsely telling, even though it was actually truck, but model is saying no, it's not a truck. So model is predicting wrong. False positive, which means, so whenever I say false positive, so which means here you are passing the image, actual image is not of truck, but model is saying it's truck. So this is what, so you should understand this from machine perspective, right? That's what I'm giving hint. If you want to understand how do I say it's false positive or false negative, right? So just think it from machine direction, right? Or machine perspective, which means if machine is predicting that image as a truck, but then you are actually passing image of not a truck, right? So machine is falsely telling it as a positive, right? That's why we call this square as a false positive. So machine is falsely telling it as a truck, but you are passing image of not a truck. That's what I mean false positive and false negative. Hope that's clear. And now, so to generate this one, right? To generate this matrix, what we are going to do is let's take example. So have pen and paper, pause the video, rush. If you want to just watch, if you're a little lazy on weekend or anything, just watch along with me. Or if you're a little bit hardworking, just take a pen paper. Okay. For example, your data set is having of 400 vehicles images. For the example, I'm not taking like 10,000 or 20k or 30k images. For this manual confusion matrix which you would be creating along with me, here I'm just taking a full data set of 400 vehicles images. Out of those 400 vehicle images, the 190 vehicles are actually truck. So 190 are actually positive, which means they are of actually truck. But out of those 190, my model is able to identify those truck images as truck. So my model is able to predict by looking at those actual 190 images, and then my model says, yeah, out of 190, my model is able to tell 150 as truck. So that's what we call it as true positive. So model is doing good job, which means true, and positive, which means it's truck. Now let's go to the, I think, reverse way. So out of 400 vehicles, now 210 vehicles are not truck. And if I feed all those images of 400 vehicles, my model is only able to identify 170 out of that 400 vehicles, right? So my model is saying, hey, whatever images you pass, but out of those 400, I would say, only 170 images are not truck. But actually there were 210. So my model could not identify, you just subtract 210 minus 170, right? So those images model falsely identify, right? So that's what we call it as true negative, right? And then let's move to the third use case where out of 400 vehicles, model identifies incorrectly 60 as a non-truck, but model says, hey, they are truck, right? So here model is falsely identifying them as a truck, which means model is identifying those 60 vehicles which are not a truck, actually not a truck, but model is predicting as a truck. So false positive, right? I had just put a question mark for you people. That was a question for you. Now imagine what would be this. This is what you need to answer. So read along with me. So if there are 400 vehicles and there were around 80 truck vehicles, so there were actually 80 truck images, but model is saying no, it's not a truck. So model is again wrongly classifying them as a not a truck, but they were actually truck, right? So false, and they were not truck, right? So negative. So even though they were truck, model is saying, oh no, that's not a truck. I hope you understood the difference between these two, right? And all four, in fact. Sorry, yeah. And then let's go to here. So here in your confusion matrix, I just put the number accordingly. So true positive, true negative, and false positive. Now, in a nutshell, ideally, this is how your green count should be increase and increase. And this count should be reduced, right? Because this is false. false prediction, right? Ultimately, this is false prediction. This is also false prediction, right? So you should reduce this. That's how you can get idea, how my model can be more perfect. Let's count. So to count confusion matrix, you need to understand once you have this kind of confusion matrix, what you have done so far, you are just creating kind of quadrant like me. In all these four squares, just put based on the whatever example that you have taken, put true positive, true negative, false negative count into the respective squares. Once you have done this, the story doesn't end here, my dear friends. The story begins with actual matrix you can use with which you can measure how your model is doing. So based on this count, let's calculate some of the matrix parameter. The first parameter is accuracy. Now, what does this mean by accuracy, right? I'll just come to that point in later. But before I go to that one, just understand this how you calculate accuracy. So this is a formula of accuracy. What you do is you just sum it up the true positive plus true negative count and you divide them with true positive, true negative, false positive and false negative summation. And this is what I'm doing, right? I'm just putting those count. So true positive, so true, this guy is true positive, right? So I put 150 plus true negative. So this is true negative. I just sum it up. True positive plus true negative. Under that, I'll calculate all four squares. So 150 plus 170 plus 60 plus 80. And finally, my accuracy of model comes 0.69. Just hold on to that concept. I'll just come on to that point as well. Recall. So what's my recall metric? So my recall metric is 0.65. How it came? True positive, and you divide the true positive count with true positive plus false negative. This is what it comes. It's 0.65. This is precision. This is specificity, and this is all the various metrics, right? And then you will count your F1 score as well. Now, just just look at F1 score, right? Because it's including precision and recall values. So to calculate F1 score, you need to calculate precision and recall before. So here in F1 score, you are including precision recall. Now this is very critical. F1 score is very critical because why you are including precision and recall, I'm just getting into a little bit, giving you more theory around it, because with F1 score, you can really understand the trade-off between precision and recall, right? Because they sometimes they might be always neck to neck, precision and recall values. So to get the trade-off between them, you are using precision and recall into this F1 score formula. So this is what F1 score, and sometimes your data might be a lot of imbalance, right? So this F1 score will help you in that case as well. Now let's come to the point, what is precision and what is recall, right? So precision, the precision is actually accuracy of positive prediction. So which means whenever my model predicted true, whether it was right or not. So for example, if I gave image of boat or if I gave image of bike and model says it's truck. So how many times whenever model predicted true, so which means whenever my model said, hey, it's truck, third time, hey, it's truck, and fourth time, oh no, it's not a truck, but actually it was truck, right? So how many times my model was right when it was predicting true, right? So this is what I mean. So when the model predicted true, how often it was right? This is what precision says. So how precisely my model is predicting true, which means if you want to look at this in another angle, right? Which means precision is like you, so sometime, so you in some of the use cases you would really look at the precision of the model. You would really care about precision model, when you do not want to miss, or basically you do not want to basically I would say, uh, you do not want to take something as a positive but it's not a positive, which means when the cost of false positive is high, which means if there is image, it's not of a truck, the image is of, for example, a boat, but then your model is classifying it as a it's false positive, your model is saying no, it's truck. So which means imagine I would say in healthcare scenario, right, where someone is not positive, maybe there is some very critical health condition, and then falsely positive. So your model is based on the parameters. Your model is saying, hey, maybe you have so and so brain disorder, but then actually it's not a brain disorder, right? But then your model is falsely positively or positive, which means you have brain disorder. So model is falsely telling that this person is having brain disorder, but that's detrimental, right? So in specific health cases or health model, the precision should be very high, because you do not want to someone classify as brain disorder person, but the person is actually normal, right? The person is having maybe something else illness. So your precision should be very right. That's what I mean by precision. Recall, or sometimes you can call it as sensitivity as well. So this basically tells you the count, right? So this basically tells you the number of actual positives your model had identified. Now here, which means whenever the class was actually true, so which means whenever someone was actually having the brain disorder, did the model got it right or not? Which means if someone is having brain disorder, whether model was predicate rightly or not. So whether model also said, yeah, it's brain disorder. Second patient comes, and based on the different features and different parameters, and model is predicting, yeah, it's brain disorder. And second patient was actually having disorder, right? So in second case, in recall or sensitivity, here you are checking whether model is getting it right or not. So recall. Now, recall, I mean, if you just take a one more deep dive, right? The recall, it's like whenever you check the recall count, right? So recall is like, you know, if you really miss any positive, right? Which means, oh, the image should be truck, but model miss to identify it as a truck, or the person was having brain disorder, but then model said, no, the model said, that no, it's not a brain disorder, right? So model is missing those positive predictions, right? Then it's a very big impact. So in those cases, in those use cases, you should really understand the recall is very important. You should give weightage to the recall. In case of recall, maybe it's okay to make someone negative as positive, but then you cannot miss out. You cannot really miss out positive, right? So here I'm not connecting with healthcare use cases. I don't want to confuse you, but what I'm saying is recall is like, you really don't want to miss any positive prediction. So my model has to really predict positive cases, right? Now precision. Precision is like, if you treat someone as, if you consider a negative as positive, right? So for example, I would say again, I would like to take example of healthcare only, right? So for healthcare, I would say, if someone is like COVID negative, but then a model is saying no, it's COVID positive. So it's detrimental effect, right? So unnecessary, maybe that person would be having those unnecessary drugs or unnecessary antibiotics. So the precision is very important in those healthcare use cases. Recall, maybe I would say, for example, fraud transactions, right? So if your model is classifying fraud or non-fraud transactions, in those cases, if you really miss any fraud transaction, the financial impact is very huge, because you miss to identify, your model is missed to identify the fraud transaction, which is a positive, right? Positive situation. I mean, I'm referring to positive, negative in earlier cases, what I just explained in the case of truck. But if there is not a fraud and you classify it as a fraud, maybe I would say it's not a big impact, right? So maybe if you consider negative as a positive, right? So if there is not a fraud, but you tell it as a fraud, right? uh, it's okay, right? But you don't want to miss any fraud transaction. So recall is very important in financial transactions, and precision is very important in healthcare cases. I hope you got idea about all these model parameters, and you were able to get idea about uh, confusion matrix. Hope you are not confused. If you are confused still, write a comment so that I can explain you more in a more detailed way. And if you are not confused, then also write a comment so that I'll understand, that I did not confuse you. So that's all for now. And yeah, this is a very basic series of confusion matrix. Sorry, this is very basic series of AI, and hope you're able to get full idea about confusion matrix in this video series. Stay tuned for my next upcoming video. Till the time, thank you, my dear AI enthusiasts and AI learners.